Hey guys, so I want to take you through the calculator work for number 2, the pollutant problem. Number 1, we didn't need a calculator for us, so I want to take you through number 2. So to start with, they gave us p prime of t. Let me show you. This is the problem I'm talking about. The pollutant. So I'm going to start by putting that into y equals. So go to y equals. Type in 1 minus 3 e to the negative 0.2, the square root of x. Alright, so for A, is the amount of pollutant increasing or decreasing? So we just needed to plug into the derivative. So what I did was, there's a lot of ways to do this. I like using the main screen, it's just out of habit. So I need my y1, where I put the pollutant, the rate of change of pollutant, y1 of 9. Is it 9? Yeah, 9. So that's my answer. It's a negative, so that means we are actually decreasing. So that is not true. For what value of t will the number of gallons of pollutant be at its minimum? So we need to know to find a minimum, where is the derivative equal to 0? So I want to know, where is this equal to 0? So I'm going to look at the graph. I usually I'll just put zoom 6. That takes me 10 by 10. So I always do that automatically, and then I kind of alter it. So in this problem, I know they were talking like 50 gallons of pollutant, right? So I'm not going in the negatives. So I'm going to change my window to 0 to 30, and I literally just pick things. I'm not really sure what I'm doing. So say negative 1 to 50, and I'm just going to see how this thing looks. Change the scaling to 5. Let's see how this looks. Well, that's not a very good graph, is it? I need to go more negative. See, window. Let's see. 10. Say negative 5. See if that helps. I need to go farther. Window. So this is literally what I do when I'm doing these, guys. I'm not like just playing the fool. I promise you I'm not playing the fool. This is how I do these. I just play around with it till I figure it out. Alright, looks like it finally hit. So I need my 0. So to get my 0, second, calc, 0. So left bound, so I need to be a little below, so it's at negative 0.1, so that works. And then to the right, so I need to move this thing so it's above the x-axis. Enter, enter, 30.173. So the cool thing about this is that graph, that x value is now in x. So sometimes what I'll do is I'll store it here. I didn't do it using the graph when I did the problem. I actually solved. So what I did was, it was ln of 1/3 divided by negative 0.2. And I got that, and then I squared it. So that's how I did it algebraically. I think it's easier because that graph is kind of annoying. So that's how I did B. Is the lake safe when the gallons are at a minimum? So that's the integral, right? So we're just going to do our initial amount. What was the initial amount again? 50. So 50 plus the integral. So math 9. I'm going from 0 to A because I stored that thing in A. And that's why I do that, honestly. It's just easier. y1 and x. Enter. There's always, see, it's working right there.